Hi children. So we come to the video where we are going to discuss sum of n terms of geometric sequence. Okay. We discussed in previous video what is a geometric sequence. You will have first term and you will have a common ratio. But somebody wants you to add all of them, right? How will you do? So let's first understand the sum of n terms of geometric sequence before we proceed to the exercise of our website examprep.world. Okay. So let's start. Suppose geometric sequence is 3. I will use my sequence which I gave you in the previous video. 3, 6, 12, 24. Is it a geometric sequence? And what kind of geometric sequence it is? Diverging. Why? Because the number of terms are, the value of the terms, consecutive terms is going on increasing, right? Eventually the infinite term will be infinity. No? Because you are always doubling it. So here what is your first term? U1 is 3 and R is 2. R is more than 1, so diverging series. R is less than 1, converging series. We will discuss those kind of sequence also. Now if I have to add, suppose this is only 4 terms. Suppose there are some x number of terms here. Somebody tells you to find sum of 10 terms. So some kids will make 10 terms and then slowly add. So sum of 25 terms. This becomes difficult manually. So we need a formula for this. So let's write a formula. Sn equals to U1 R to power n minus 1 over R minus 1. Now copy this formula in your notebook. We will be using this for diverging series, diverging sequence or series. So here how do you identify R should be more than 1? That's why R is before 1. Otherwise you will get a negative number here in the denominator, right? So remember it like this. This is for R is more than 1. If R is less than 1, like it's a ratio like half, 1/3, then the formula will be Sn equals to U1 1 minus R to power n by 1 minus R. This is for converging sequence where R is less than 1. Anything can be less than 1, half, 1/3, 1/4, right? So for them you will use this formula for diverging. This is a diverging series, so you will use this formula. Okay, understood? So can we begin with the questions? So let's begin with our exercise. I've got 1, 2, 3, 4, 5. I'll do second one for you here in this video, and I will do D. Right? Why I'm chosen? Because I feel that you may find it little complex, so I'm helping you out here. And we will also do E, because positive, negative, it's alternating. So we will do that. Okay, so let's start with B. What is U1? U1 is 2. So I'm doing B for you here. B. Right, always capture U1. U1 is 2. What is R? 10 divided by 2 is how much? 5. 50 divided by 10 is also 5. So R is 5 in this case. Now we have to add up to 9 terms. So typically what we have to do, we have to find S9. Okay. So S9 will be, I'll write the formula also for you so that you always recollect. Sn is U1 R to power n minus 1 divided by R minus 1. R is 5, so it is a diverging series. I will use this formula. Okay. So let's apply. That implies S9 is equal to 2 5 to power 9 minus 1 by 5 minus 1. Now pick up your calculators and do this. Big number. $976,562. That is the sum of these terms. Manually it was not possible to do it, right? So now you use the formula and you have found the sum of 9 terms of that sequence. Okay, pause, do it yourself. Now we do the D part. Okay, D question. We'll do D for you now. Okay, what happened? D is here. D is 11 root 11, 11. So U1 is 11 root 11 and R is 11 divided by 11 root 11, which is 1 by root 11. Now tell me here R is less than 1 or more than 1? It's less than 1, right? 1 divided by any number, right? Root 11, which is obviously 3 point something, right? So it is less than 1. So which formula I will use? I will use the converging series. This is a converging series. Okay, be careful. Don't use diverging series formula there. So S, how many terms? 9 terms. We have to add up to 9 terms. S9 will be U1. This time we will do, I will write the formula for diverging series once again. Sn is U1 1 minus R to power n divided by 1 minus R. Okay. This time 1 comes in front, R goes to the next side. Okay. Let's implement 11 root 11 1 minus 1 by root 11 whole to power 9 1 minus 1 by root 11. Now pick up your calculators and do this. 23. I got 52.23. That should be your answer. Okay. Now you want me to do E? Let's do E. Okay. Let's begin with E. Now here we have U1 is 16, U1 is 16 and R is negative 4 over 16, which is negative 1 by 4. Here also R is less than 1. We will use the same formula which we used before. And how many terms? They are asking us S10. So I will write S10 equals to U1 is 16 into 1 minus R is negative 1 by 4 whole to power 10 divided by 1 minus of minus 1 by 4. Okay, let's now use calculators. It is 12.80. With that, this type of questions you understood, right? What we are doing, we are adding sum of n terms of a GP. Let's see what is the next. Here in this thing they have given geometric sequence S1 is 2 and S2 is 8. Now tell me with logic, if S1 first term and its sum is the same thing, right? So S1 and U1 will be basically same because single term and add the single term, it gets the same value. So if they give you S1 is 2, that implies U1 is also 2, correct? And S2 means sum of first term. S2 is U1 plus U2, right? This one they have given you as 8, but U1 is how much? 2. U1 is 2. How much U2 will be? That implies U2 is 6. See, add them, 8. Okay. Now you have to find common ratio. Now since it is a GP, you have U1, you have U2. R will be U2 divided by U1. Second term divided by first term, which is 6 by 2, which is equal to R. Okay. Now you have U1 in your hand, you have R in your hand, which is 6 divided by 2 is how much? 3. So we have to find sum of first 10 terms, S10, and R is this time more than 1. We will use divergence series formula. Okay. So it is U1, which is 2, R is 3 to power 10 minus 1 divided by 3 minus 1. So 2 cancels, 3 to power 10 minus 1. See, this is 2 and 2 cancel off, 3 to power 10 minus 1. So 3 to power 10 minus 1. 59,048. 59,048 is your answer. Okay, understood now? It's very simple. Direct application of formula, nothing else. Only thing you should remember formula. Now don't tell me that in IB they gave us data booklet, question formula booklet, At the time of exam you will not get to know which formula to use. So it is very simple. Remembering the formulas, no, it actually saves you a lot of time. A question which takes 15 minutes, you will be able to do it in 5 minutes. Okay. So always write the formulas. Big deal in remembering the formula. It is very simple formulas. You can do that. Okay. Now let's go to the next question. We have been given one sequence and some 6 questions from the same sequence. Let's do them. 10, 5, 2.5, 1.25. What kind of series it is? Converging series, right? So what is U1? It's 5. What is R? 5 divided by 10, which is half. So now we have U1 and R. Once you have these two things, probably the whole sequence comes under your control. Okay. What is first term U1 and the common ratio? A question is answered. Find 10th term of sequence. This was for A, B. U10 is U1 R to power 9, isn't it? So which is 5 into half to power 9. Half you can write as decimal also and you can calculate. So let's do that. 5.5 whole to power 9. 0.01. 0.01. I am keeping my calculator in 2 decimals, so I will leave it here. You can set it for 3 decimals and you can write your answer like that. Okay, so B is done. Find the sum of 10 terms. It is a converging series. S10 will be U1 is 5, 1 minus 1 by 2 whole to power 10 by 1 minus 1 by 2. Calculate, we will get our answer there. So it is 9.99. 9.99. I'm sure it will be 9.99999. Okay. So C is done. Now let's do express the general term UN in terms of N. UN in terms of N. D. We know U1 is equal UN is equal to U1 R to power N minus 1. So they basically want the general rule 5 into half whole to power N minus 1. So we have expressed UN in terms of N. Instead of half, you can write 0.5 also. Okay. Find the value of N when UN is 0.3125. This is a typo thing. Don't see this. It is 0.3125. Okay. What is the value of N when sum of N terms is that? So let's do that. Not sum. UN itself is this. So we have general formula for UN. What we will do, we will equate this to 0.3125. Okay, this equal to this, we can calculate N. How? Let's do that. So we have 0.5 whole to power N minus 1 equals to 0.3125. Clear? So send this 5 over here, bring it here, from here remove it. So it is 0.3125 divided by 5. I have to change my calculator to decimals. Shift. 0.0625. So 0.5 whole to power n divided by 0.5. I am writing it like this. Okay. N minus 1 is n minus 1. I am using the techniques of exponents, right? Equals to 0.0625. Yeah, that's right. So 30, 1, 5 2s are 10, 5 5s are 25. Decimal is after 4 places, 0.0625 is fine. Now 0.5 whole to power n equals to 0.0625 into 0.5. How much is that? Which is 0.3125 equals to 0.5 n. How do you calculate this one? Now you have to use logs. I hope you are good in logs. So log of 0.03125 to base 0.5 will give you your value of n. This is how we do this. Okay, let's do that. So log of 0.03, this is the base, 0.03125, 5. N is a complete number, 5. Okay, so we calculated the value of n. For what value of n? N is 5 here. Now copy, and if you have forgotten this method, I will definitely put some videos on logarithms, right? There you can go and learn logs. Okay. Now, what is f? Before that, if you want to pause the video and copy this, please copy. I'm moving away from the screen. Okay. Now let's do f. Explain why the sum of infinite series exists. I discussed in the previous question. It exists because the infinite series is converging and becoming a very small number. So it is possible the last number will be very close to 0 and the last few numbers are exactly, total of all the numbers will not be even 1. So it is possible to calculate the value of infinite sequence. Okay. So you should write the infinite series exists because a converging series, it is reaching 0. It doesn't reach 0, it is tending to 0. You can write that word, and hence we can total all the numbers for S infinity. What is the formula for infinite series? It's most easiest thing. Although they have not asked formula here, I am giving you formula. You should know this. For converging series, sum of infinity. Sum to infinity is simple, 1 minus u1 divided by 1 minus r. This is sum to infinity formula. For any converging series, you can find the sum up to infinite terms using this particular formula. Okay, let's go to the next one. Here, they are asking us sum of infinite geometric series. They have told that it is infinite geometric sequence, so definitely they are converging series. Let's see and check. u1 is 1 and u1 is 1 and u2 is 2 upon 5. So r is u2 divided by u1, correct? So 2 by 5 over 1, which is 2 by 5. You say this 2 by 5 is less than 1, it's a fraction. So it is definitely a converging series. Now you have u1, you have r. Straight away sum to infinity is u1 divided by 1 minus r. 1 divided by 1 minus 2 by 5. 1 divided by 3 by 5, which is 5 upon 3. That's your answer. Okay. See, very simple. If you get this question, in 2 minutes you will get your 4 marks. Now it will be definitely a 4 marker kind of question if at all it comes. Okay. Now let's do the other one. Let's find r. It's basically same thing you see, but it's negative. So u1 is 1 and r is negative 2 by 5. Because the second number is a negative number, third number is also a negative number. Negative divided by positive is negative. So r is negative 2 by 5. So here S infinity will be equal to u1 by 1 minus r. Same formula. 1 divided by 1 minus of minus 2 by 5, which is 1 divided by 1 plus 2 by 5. Here it was minus, here it has become plus. So 7 by 5, 7 by 5, 5 by 7. Answer is 5 upon 7. Okay, that is sum to infinite terms for that particular sequence. Was it easy? Sum to infinity is the easiest question. Never get anxious about this kind of question. The formula is also simplest and the working is also very simple. It is just u1 divided by 1 minus r. Now, they have given, we have to find u1 and common ratio. They have given some terms like u7 and u10. So, translate this into general formula rule. Like, let us do A. They gave u1 as 3645, and so what I can write here is u1 r to power n minus 1 is equal to 3645, isn't it? So, it is 7th term. Sorry, I am so sorry. Okay, come back. Let's do A. u7, they have given u7 as 3645. So u7 is what for us? u1 r to power 6 is 3645. I translated u7 into its general format. Similarly, they have given u10. So I can write u1 r to power 9. 10 minus 1 is 9, is how much? 98415. If I divide the first expression by the another, I will cancel off the u1 will go. R by 6 divided by r by none, it will be r cube, and here you will have 3645 divided by 98415. Is it 98415? So let's do that. 3645 divided by 98415. It is 1 over 27. 1 over 27. If 1 by r cube is 1 by 27, isn't it 3 cube, right? 1 by r cube is 1 by 3 cube. Then what is r? R is 3. So we have r as 3. Now can I input anywhere? Here, I will input here. So I will get u1 value. So u1 r 3 to power 6 is 3645. Therefore, u1 will be 3645 divided by 3 to power 6. And calculate. We get a number 5. So for this one, u1 was 5 and r was 3. First one. Easy? You want me to do the next one? Let me do it. Because you have kept it on board, let's complete. Pause, write it. I'm moving away from the screen. Okay, written. So let's do the next one. We have once again u7. So it is u1 r to power 6 is 98415. And u10, which is u1 r to power 9. u10 is u r to power 9. u1 r to power 9, 3645. Right? The numbers are same, they have just flipped it. So basically divide this one. So u1 goes, 1 by r cube is 27 by 1. Therefore, flip it. R cube is equal to 1 by 27. Therefore, r equals to 1 by 3. Now you have value of r, right? If you have r, input in here. So u1, 1 by 3 whole to power 6 equals to 98415. Therefore, u1 will be equal to 98415 divided by 1 by 3 to power 6. Right? So basically you have to multiply 3 to power 6 into this. So let's do that. 3 to power 6 times 98415. It should be a very big number. Yeah, it's a very big number. It is 717 44 535. 71,744,535. That's our answer. Okay, understood this type of question? So with this, we come to end of questions where we are trying to find sum of n terms of a GP. So keep practicing. Thank you.